Thank you for joining us for the Utah Energy Code Lunch and Learn training. Today's topic will be on residential building envelope as related to energy code. I want to thank our sponsors, Rocky Mountain Power, Dominion Energy, and the Office of Energy Development for the state of Utah. This partnership has led to hundreds of builders, contractors, developers, building officials, and other subs, including HVAC contractors, to gain a better understanding of Utah's residential and energy code. And we want to let you know that these will be happening the second Thursday of every month for the next 3 months. And I also want to thank the Salt Lake Community College and specifically the Energy Management Program, and also the Utah Home Builders Association for being our partners in this endeavor. As you'll hear in just a moment, I will have Alyssa come here from the Energy Management Program to just give a couple words about the program. And just want to say that there were brochures available. If you're watching online, these can be emailed to you. And we have various things from our Residential Energy Code Quick Guide brochure, which gives you an overview of the pertinent energy code codes and information that you should be aware of. We also have the Residential Energy Code Compliance Paths. This is a great document to understand how to meet energy code, and one of those being with the help of a HERS rater. We do have many home energy raters, also known as HERS raters, in our audience today and online. And we do have a list of those home energy raters who are available to do this work, available for you as well. The brochure is right here, and I'm happy to send it to anyone as far as the next 2 energy code trainings, and just want to make sure that that is available to you. We will take a break at noon, so if you're online, you can plan on a break for about 10 minutes from noon till about 10 after. We will have our lunch for those here in person, and please silence your phones for everyone here, and you can find, if you need to make a call out in the hall, those resources available to you. Alyssa, would you like to come up and give us a couple words about Salt Lake Community College's Energy Management Program?
Thanks, Becky.
Yes.
So my name's Alyssa Kay. I'm with Salt Lake Community College with the Energy Institute. We offer training in all aspects of clean and renewable energy. So we have training programs in solar installation, solar sales. We have an associate's degree in energy management. We also have several energy management certificates, including energy accounting, energy efficient lighting, HVAC, energy modeling. We also train line workers, the people that work on the power lines. So if you have an interest in any of those aspects of energy, if you know anybody who has an interest, I have some brochures up here, and my number is on most of the brochures or other program managers with the Energy Institute. So please contact us and we can give you more information on when those trainings become available. Actually, the next training we have coming up is energy efficient lighting, and that one starts in May. So, all right, that's about it. Thank you so much for being here.
All right, thanks, Alyssa. As you may know,
You don't need to read all
okay,
that.
Brent Ursenbach is a top building official with Salt Lake County, and he helps us with these trainings. And as you may know, he was an HVAC contractor for many years, 33 to be exact, and so we are lucky to have him here as our trainer. Thanks.
Thank you. Get this back where I need it to be, where they need it to be. Good morning. It's great to be here. Becky mentioned that we're going to do this for the next 3 months. I'm actually hoping that we can do it for years. You know, we did a Morningside training about 5-6 years ago, and it was very effective. And the thing I really like about it is you can send me an email or someone an email and Becky an email and say, hey, let's focus on this one subject, or let's focus on this, you know, one subject or another. And these are going to be short, 2 hours at the most. We will not, maybe, Troy, you're going to want me to touch on something that I didn't include. You know, I only put in about 2 hours worth. But I think you don't want to come and sit through an all-day class if you just want to learn a little bit more about HERS raters, or if you want to learn a little bit more about the mechanical system, or you want to learn a little bit more about another aspect of the code. And we have a commercial code and we have the residential code. So my suggestion to Office of Energy Development, and I'm a slide ahead, my suggestion is that we continue and do these every month, second Thursday, and address the things that you'd like to hear. I do want to thank Alyssa and the community college for making this possible. I mean, they've been super to provide, training spaces here for us. Really easy to work with. They always are making sure they can find us a room. And besides that, it's only about a mile away from my house, so it's great for me to come here. I do work for Salt Lake County. I'm leaving Salt Lake County at the end of the month. I still will be doing training. I have at the end my email address, 2 email addresses, and 2 phone numbers. The county ones will go away, but I have personal ones there. I will be still working with Office of Energy Development indirectly to continue doing trainings after I retire. So I'm not going away. I will still be a resource. If you have a question, shoot me an email, and they're going to be paying me to be available to answer those questions. So don't panic or don't feel bad if you send me a text or an email and say, I apologize for disturbing you. I know you're retired. Well, they're going to compensate me for that. I will, however, not be available every day because I will be playing. So, some of you have attended my previous classes, and you'll see a lot of slides that are familiar. You'll see some new stuff that I have not had in any. I put some new stuff in last night. But my focus is going to be just on the envelope. Now, we're going to touch a little bit on how the HERS rater ties in on the envelope. Please, if you have a comment or a question, raise your hand. Please try to keep your question short because I need to repeat it so those online can hear it. And if you go on for 3 minutes, I'm going to paraphrase your question the quickest I can, so just short, concise questions, and we'll try to address them. And this really ties in with the envelope. As an HVAC contractor for years and years and years, I would go into an existing home and I had to make a judgment call on what the windows were, what insulation's in the wall, because so much is buried. Well, the code now for a couple of code cycles said, let's have a label that we put, previously it said, put it in the panel. Well, there's not room in the panel, and so it now says, provide a permanent label, mechanical room, someplace that's obvious, that identifies what the insulation is, what the U factor is on your windows, what your HVAC equipment is. So at least we have a starting point in the future. My dream is that one day, these guys that are HERS raters are going to be going in and rating every single home that goes on the MLS. That we are rating every home that's put on the market so that we can truly see an energy score for every home. So the public, my grandkids, great-grandkids, whatever, can make a wise decision when they buy a house on what the energy usage is going to be. What's the greatest expense after a mortgage in owning a home? Utility expense. It's higher than property tax. It's the greatest expense. So it's an important thing. This label just needs to, and I don't need to read through it all. I think most of you are familiar with it. It's on your slides. If you want a copy of my slide for this presentation, send me an email and I'll send you a PDF of it. It does not want you to list efficiencies on a baseboard electric heater. If we go to Walmart and buy a baseboard heater and wire it in and stick it on the wall, it's technically 100% efficient, but it's also 100% expensive to operate. And so the code doesn't want you saying that's 100% efficient, people being misled that it's the most effective electric way to heat. The structure of the code, and I'm going to just load these all up. The residential energy code is, for the most part, an envelope code. Now, it does have some mechanical requirements tied to it. It has, some control requirements and piping insulation, equipment sizing, and dampers and lighting. But for the most part, it is a envelope code where we identify the insulation, the U factors, R values of the thermal envelope. Now, what's a thermal envelope? I think most of you know, but the thermal envelope is that set of components that separate conditioned from unconditioned space. So all you have to do is think about what's the temperature on each side of a component in the building. These walls here are not part of the thermal envelope because we're just separating two conditioned spaces, but this wall and these windows are part of the thermal envelope because we're separating conditioned from unconditioned space. So those are the things we're worrying about. And those are the places that we have heat moving one way or the other, whether it's out in the wintertime or in the summertime. So we're going to look at roofs, above grade walls, foundations, basements, slabs, crawl spaces, skylights, windows and doors, solar heat gain coefficients. And we are going to come down in this mandatory set of requirements at infiltration control. Infiltration, the leakage of air in and out of that envelope. And so we are going to spend a little bit of time on that. And we are going to not discuss these. So that one item we're going to touch on. And we have, where I have red, I'm trying to identify something that's different from the 2012 code. This is a 15. I failed to mention when I started, hopefully if you don't have one of these, you need to make sure you have one. The legislature a year ago amended the residential energy code. And there's a number of amendments in here, and we'll talk about them. What this handout is a page. Every page that has an amendment from the energy code is included in this handout. So if you open it up and you see red, that's an amendment. So anything that's marked in red or any text added in red is amended, and that is code in Utah. And it should be code everywhere in Utah, not, and I know Troy's kind of laughing. It's code everywhere. Is it enforced everywhere uniformly? No. And so I've tried to use the red here also. Okay, I cannot begin a discussion on energy code if we don't talk about our compliance paths and our compliance options. Becky talked about, we have one little sheet that's kind of a flow chart that you can use, and it parallels this. But for many, many years now, we have had generally three methods that we can comply with the energy code. We had the first one, which was a prescriptive method. We have a table, and it's basically a recipe. We put windows in that have now a 0.32 U factor, R49 in an attic, R20 in a wall, R30 in a floor, and we just have this recipe. And if you meet every one of those requirements, you comply with the code. Well, as much as some people dislike an energy code, it does give you a lot of flexibility. It doesn't tell everybody you have to build a home this way. You can build it the way you want to, innovative ideas, be unique, because we have 4 options recognized in the code to comply with the code. So this baseline is this prescriptive table, and we just follow exactly what's in the table. Now, if you have windows that don't quite meet the table, or if you have a wall assembly, for instance, if you don't want to build with 2x6, you want to build with 2x4, you can actually build with a 2x4 wall with an R13 or R15 bat in it and be stronger someplace else. And so you can trade it off, and that's what we call the prescriptive UA trade-off, or res check. And I think a lot of you are familiar with res check. We have the simulated performance approach. That's a modeling, REM design, is that right? A couple of those different softwares that you can model the home. and you basically have a standard reference design home that has similar dimensions to what you propose to build, and you compare the two, and if your proposed home will use less energy than that standard reference design home, you comply with the code. New is the energy rating index, or HERS rating, and that is one where, similar to the modeling, but it takes it a little bit further, and it looks at your other appliances in your home. And so it takes into account more the whole energy usage in the home than the simulated performance approach does. And this is the one that I really am excited about. This one, we're not seeing a lot of it yet, but there's a lot of potential in there for you to build exactly the way you want to. Where I am seeing this being used probably the most is in Washington County, St. George area, where they want to use budded glass. How many know what budded glass is? Half-inch thick, solid panes of glass, not 2 panes, just half-inch glass, and they just butt them together and just seal the thing, so you have this wall of glass. Yeah, it's very inefficient, right? I mean, the U factor on that wall is 1 or a little higher. It's not good. However, if someone wants to build with that, they can do the ERI approach or HERS rating, and they can put in really efficient appliances. They can go in all these other areas and step up and drastically improve in other areas so that they can have that wall with that view. Larry's shaking because he saw it down there in southern Utah. Very popular. And until we came here, it was very hard to get it to work. Extremely hard. A couple of times you could sneak it in with a 2012 res check, but that was the only way, and you couldn't get it all the time. And so I am seeing that happen. Am I saying I love that? Well, no, not necessarily, but this is America. If someone wants to build a house like that, we need to give them a path that they can do that. All they need to do is do some really good stuff in other areas. You have a comment, Troy, or are you just...
No, I'm just chuckling at the notion of leaving a big thermal hole in your house and building up other places to compensate for it, as if it's going to close the one.
Yeah, it is a big thermal hole. There's a ton going through. I was doing a short class yesterday for Rocky Mountain Gas Association, and one of the guys said, well, why don't we just build old leaky houses, because then we didn't have to worry about ventilation and all this stuff. And the big reason is, and this is a problem that these people are going to have with these, is comfort. When you have something that's really poor in performance, even if you comply with the energy code, you're going to have a comfort issue in that area. And you sit by that glass when it's cold, you're going to feel a draft, and it's those convective flows that are running on that glass. But it's an option, and again, someone can do that. Would I do it? No, I wouldn't, but we're all different, correct? And we have a fifth option, and this is by state amendment. And that is that we can still use the Utah 2012 res check. Now, the Utah 2012 res check is a res check written by DOE specifically for Utah to fit the 2012 amendments that were made to the energy code. If you choose this option, you have to pass right now by 3%. Starting next year, you got to pass by 5%. So that is a method still. And the reason this was put in is because your Home Builders Association, and I'm not saying this is wrong, they wanted to keep the equipment trade-off. What's the equipment trade-off? The equipment trade-off says, well, I'm going to build an envelope that's not compliant this way, so I'm going to build with 2-by-4 walls. I'm going to put R13 in them, but I'm going to put a 95 or a 97% efficient furnace in where the code only requires a 78, and I'm going to get credit for the furnace efficiency. You can't get that with the 2015 res check. In fact, it disappeared from res check in 2009. So that gives you that equipment option. That's the big reason that's in there. we'll start the discussion some point in the future. We really don't need this with this because you can get credit for your high efficiency furnaces and air conditioners with the ERI path. Troy.
What path are builders using today to meet energy code? Yeah. So obviously they've got options, but you see a lot of things come across your desk. Primarily, is there one method that's being used more than others?
The question is what path is being used today, and I'm finding it varies depending on areas. Like I've hardly ever seen homes using this, but my friend Ron MacArthur has used that extensively over the years in his projects, not in my jurisdiction. What I've seen in the unincorporated portions of Salt Lake County, for the most part, is ResCheck. That's what, Wendy, what do you see the most? Mostly ResCheck, Larry? Right, Chris?
2012 ResCheck.
2012 ResCheck, yeah. And that's what we're seeing. This is a good time to make a real critical point. Because we have an option to use the 2012 ResCheck, I've read it very closely. There is nothing in the amendment that says you can use the 2012 prescriptive table and call it prescriptive. Do you understand what I'm saying? You cannot show compliance, say, well, I'm going to do prescriptive 2012 because I can use the 2012 ResCheck. No, that's not what the amendment says. The amendment was specifically written to allow the equipment trade-off. It was not written to replace the 2015 prescriptive table. So if you want to build a home and follow the prescriptive table, and where we see compliance to the prescriptive table a lot is on add-ons. You know, when they do an addition on a home, lots of times they just go to prescriptive and they meet that. Now, our high-end homes up in Olympus Cove, which as of the first of the month is not part of the unincorporated Salt Lake County, Mill Creek City is doing that. A lot of those high-end homes where they tore down and built a new house, they easily could comply with the prescriptive because they're putting in real good windows, they're doing real good insulation packages, and they're doing all these things. And they turn in a ResCheck that's wrong. What do? Do you tell them, well, your ResCheck is wrong, redo it? Well, what I tell them is, your ResCheck is wrong, this is what you did wrong, but you don't have to do a new one. You meet the prescriptive requirements. Make sure that's on your plans, and let's move forward. Any questions on that? Please.
Brent, is this the new ResCheck or the Utah 2012? Isn't that supposed to be 4%, not 5% for 2019?
Oh, I think you're right.
Just verifying.
I'll check that when we take a break. In fact, I think it might go 4%.
And then 5 in 2021.
Yeah, it is. Yeah, you're right. That's supposed to be 4%, and then 2021 is when we go to 5%. Thank you for that correction. I've done this a whole bunch of times, and I think someone mentioned to me and I forgot to fix it. But thank you, yeah. So next year, you have to go to 4%, and then in 2 more years, you have to go to 5%. Troy's checking it right now, right?
That's correct.
You know.
I just looked at it too.
It is 4%.
More than 5.
Than 5. Thanks. Appreciate that. Any other questions, comments? Now, I want to make one more. Really, like I say, most of this is envelope. Those that are in a jurisdiction, and those of you who are builders, I'm going to tell you both. The building official is not correctly interpreting the code if he says you have to do a ResCheck, or tells you you have to use prescriptive. That's the only thing we're going to accept. That's not what the code says. The code says you have the options, and by amendment we have 5 options, and the jurisdiction really should not be saying you have to pick one of them, and those are the only ones we're going to accept. What is the building envelope? It consists of fenestration, which is windows and doors, anything you stick in those holes you create in your building. Your ceilings, your walls, which includes above grade, below grade, mass walls, and we'll talk what those are, floors, slabs, crawl spaces, with an exception. Guess what? We don't have to worry about the building thermal envelope if we have a heat source that is less than 3.4 BTUs per square foot, or 1 watt per square foot. It's the same thing. Is that realistic? Are we going to build a house and not insulate it and put in 1 watt per square foot or 3.4 BTUs per hour per square foot? Absolutely not. What if we go down the street here, there's a Walmart right over there, and you buy a little plug-in heater. What's the biggest plug-in heater that you're going to buy? A 1500 watt, right? You plug into a 20 amp circuit, 1500 watts. That in a 1500 square foot home would qualify as a low energy building. Now a 1500 square foot home with one of those little heaters would not work even if you insulated it really, really well. So it is simply a low energy usage exception for if you have a fairly substantial building and you put a little spot heat source to prevent a hose bib from freezing or something like that. It is not, I don't know how anybody else could ever use that. So we're looking at a thermal envelope, and in this example, it goes around here like this. It could go up and actually pick up here, right? Go across and pick up here. So we could put that crawl space inside the thermal envelope. We put basements inside the thermal envelope all the time by blanketing the walls even though the basement isn't finished. That created some confusion, so we fixed the code where it defines conditioned space similar to as ASHRAE has defined it. We don't have to put supplies and returns down there. If they insulate the perimeter walls and you have an uninsulated floor here, it's indirectly conditioned through the floor, or the ductwork that might be running through there will indirectly condition it. There's no requirement that you have to put supplies and returns in it. Please.
Brenda, in this month's ASHRAE Better Building, they talk about a net zero home, and they included transfer grills into the attic, include the attic in the conditioned space. Do you have any insight on that? I just was curious and haven't looked into it, and if it's out of place in this, that's okay.
No, that's a perfectly legitimate question. The question is, ASHRAE had a discussion where the attic is conditioned.
An NIST home.
Yeah.
Net zero home.
A net zero home. And what they're doing probably is either putting foam on top of the roof, and we're going to have some pictures of that, or they're spray foam on the underside of the sheathing. And that you can do, and what we're doing the same thing as we did with the basement, where you have a truss system on your roof and you insulate up against the bottom of the roof deck. You're creating a thermal envelope in the attic, which includes the attic. And yeah, it is recommended that you have some transfer grills so at least you get some air movement, similar to when we create a conditioned crawl space, that we have some movement of air through there. Please.
So when you do that, and you don't finish your basement, you don't have any supply returns in your basement, it's considered conditioned space. You don't need to insulate your ducts to the remaining floor, correct?
Correct. The question is, so if we do this blanketing of the basement walls, we don't have to insulate the ducts because they're inside the thermal envelope. That's correct. Now, I've had some people say, well, you got to put supplies and returns. No, we don't have to put them in there. When we do that, we have the walls blanketed. That basement's going to stay around 60 degrees, 62 degrees even, when you insulate the walls. And it's actually more efficient if we don't need it more than 60 degrees to not add runs down there. Do we heat it to full 70 or 72 degrees? So it's inside the thermal envelope. The duct is inside the thermal envelope. The only issue, and we're going to get to it, is what if the furnace is in there and we have an open combustion air duct? And we will address that here a little bit later in the presentation. So here is the new prescriptive table. If you want to go prescriptive, or someone wants to go prescriptive today, they have to follow this table. They cannot use the 12. I'm going to repeat that again because I've got a lot of questions on that. You have to use this table. These are not amendments. These are values that changed between what we were on before and what we're on now. So they're new numbers. Climate Zone 5, where we are right here. Wendy's in Climate Zone 6. Any others? Well, Magleby builds in Park City, and you build a lot in Climate Zone 6, don't you? Yeah. So, and then southern Utah, if you're in Washington County, you're Climate Zone 3. So that's the only reason that I only marked 3, 5, and 6. So that's an improvement on the windows in Washington County, as is this and this in Climate Zones 5 and 6, 0.32 U factor on the window. That's down from 0.35. 6 years ago, that would be a challenge. But now, when I do inspections, I'm sure those other inspectors in here, you walk in and we're seeing lots of windows that are still 2 panes of glass that have U factors that are 0.30, 0.31, 0.28, 0.29. And so glass technology has caught up with it. The manufacturers are building better windows that get that U factor down and improve that U factor on it. For those that don't know, the U factor is just the inverse of the R. So when you have a 0.32 window, the inverse is 1 divided by 0.32. We just passed R3 on a window when you put it on a 0.32 window. Still not great compared to the rest of it, but it's an improvement. We do not have a requirement for solar heat gain coefficient in Climate Zones 5 and 6. However, you get credit for your solar heat gain coefficient when you do res check and you do the performance modeling. And we'll talk a little bit more about that. R49 is new in Climate Zone 5 versus 49 was the standard in Climate Zone 6 before. And we are now 20 or 13 plus 5 for Climate Zone 5 on a wall. That means you can put a 21.
Sorry.
Oh, is this a question?
Yeah. Go ahead, finish your
Yeah, I'll get to it. R20, you're going to have a tube of 6, right? And you can buy an R21 bat, or you can net and blow it to get 20. Or you can build a 2x4 wall and put 13 or 15 in that cavity and put 5 continuous on the outside. Now I want you to notice something new that wasn't last year. If you go prescriptive in Climate Zone 6, you have to put continuous insulation on the outside. Anybody want to take a stab on why the code is saying, you know what, we really need to move towards continuous insulation on the outside in Climate Zone 6, 7, and 8 because they're cold? Why would we want to do that?
Rhetorical, or are you looking for an answer?
I'm looking for an answer. It works.
To get the dew point from outside of the middle of your wall.
To get the dew point moved out so we're not condensing on the inside of the wall. And I have some slides that I threw in just for the last one. This is really the direction the code is going, and if any of you have attended and listened to Mark LaLiberte or any of those other guys from Construction Instruction, they pound on this thing. We're having more problems rather than less problems because we're not addressing it. We are creating conditions where we are condensing moisture in walls and then we're not allowing it to dry. And OSB is not our friend when it comes to water because it really goes to hell in a hurry when it gets wet. So just an important note, this is what the code, these are experts that write these and submit these proposals. They're really pushing that in these cold climates, we try to keep out of that area where we're going to be condensing in our walls. Basement walls, you can either do continuous at 15 or 19 in a cavity, and the same for a crawl space. Slab edge insulation didn't change, floor insulation didn't change. Is 49 going to make a big difference? Nope.
Can you drop that to 38 if you get full depth to the
Yes,
Okay.
and I have a slide in there.
energy field?
Yep, we can drop that to, you can drop it back to 38. It's all you do is use a high heel truss. So you get 38 all the way to the perimeter of the building. And it's been in for a while, and I had this question yesterday, can you build with logs? Yeah, if you have at least a 5-inch log. We have an amendment that allows you to build prescriptively, and it requires 0.31 windows, at least 90% efficient on a gas furnace, and meet all the other requirements. That probably should be looked at because it hasn't been updated and it hasn't been tightened, and the windows should probably be made a little bit better. Any other question on that table? Okay, we have some questions that came in. When will homes on the MLS be updated to show energy ratings? I don't know. California currently has a requirement that when a home is on the market, the buyers and I believe the sellers are supposed to be given a little booklet that talks about testing and scoring homes. So that's their first step, is everybody needs to be aware that they could, as a condition of the sale, require a HERS rating or some type of analysis on the home to identify what the insulation is. And I would actually, in my opinion, I'd prefer that be driven by the public, and the public starts saying, hey, I want that. Just like a home inspection is pretty much standard now. There's no law that says you have to do that. Some mortgage underwriters might require it. But if the mortgage underwriters and the public demanded it, it would just take place. And guess what? The battles over energy code would be almost non-existent because people would actually realize, I'm going to get money. My house is going to be worth more because I'm going to make it more energy efficient, and that you get real value for it when you score the house. Who would be doing this, the inspector or someone else? It would be a HERS rater that would be doing that. You wouldn't want to do that on every house that goes on the market, would you, Jeff?
I couldn't right now.
You couldn't right now. Will this requirement to list on the MLS or an option? Right now, in fact, I think there's a checkbox, isn't there, on the MLS paperwork? I think there, anyway, I've heard there was talk of putting a checkbox on there, has the home been rated or tested or something. There's no requirement right now. I would love it if the realtors would jump on board with it and see some value there, because I think it would make some homes more saleable and others less. But I think it would be good for the buyers and the sellers. Okay, fenestration. I already mentioned what it was. Our skylights, our windows, our doors, whether they have glass in them or not, this is all fenestration all the way around. And in climate zone 3, we have a U-factor solar heat gain coefficient requirement. And in our climate zones, as we saw in the table, we only have a U-factor requirement. Same for the skylights. Okay, we do have the option here, and some of you have seen this before. The energy code also allows you to put grandma's stained glass window, or if you take a class on making stained glass windows, you could make a stained glass window that is 15 square feet of glazing or less, and you could ignore it on your energy compliance. We're not going to look at it. This was a prescriptive path only option in the code. It has been amended, so it doesn't matter which method you use. So the best way I can suggest you to show compliance, since ResCheck doesn't recognize it, would be if someone has one of those windows or a 24 square foot single hinge door, is you just leave it off. Just leave it off. Don't try to account for it in your energy model or in your ResCheck. And it's just a flexibility thing. The other thing that's important to understand, and some people tell me that's not right, if you use prescriptive, you do not have a limit on how much glass you have in the building. You could build a house that's virtually all glass all the way around, and as long as the glass was 0.32 or lower, it would comply with the prescriptive table. There's nothing in there that says you can only have 30% or anything like that. Now, when you go to the modeling, then we have limits that are placed on it that are fairly stringent, and ResCheck actually has built in it, some limits that's placed on it. So, large wall areas, large window areas, you can have them prescriptively. The challenge is when people want big windows, what do they usually want? Aluminum frames, and they're contemporary style houses, and it's really hard to get an aluminum frame window with a U factor down at 0.32, simply because even a double thermal break aluminum frame has a poor thermal performance.
Hey, Brent.
Yes?
Question for you. So I have a couple things that recently called out on my res checks in the basement, the under porch storage and cold storage, where that opening is. They called out that it requires a door. I've had one city say they just want to see that opening on the res check, just rated as nothing. Is there something in the code that requires some sort of requirement for that cold storage opening?
So the question is, you're blanketing the basement walls, correct? And you have cold storage under the porch. Is there a requirement in the code for that, putting something in that door? Well, you created a thermal envelope, and so you either wrap in and insulate that cold storage and insulate the top, or put a door on it. Now, most homes pass easily whichever method they use. And I allow the same interior door if they put a threshold on it, if they pass by any percentage at all, because that hollow core door actually has a U factor that's close to 0.35 or 4, something like that. I mean, if you did an area weighted average, and we're going to do an area weighted average calculation here just shortly, I can show you that even if that door was a 0.48 or something like that, which I think would be better, just an interior door, that you could do an area weighted average and trade it off with the rest of them. So I'm just a slide or two away from doing an area weighted average calculation, and we'll show you how you could make that work. But it does need something. We got to complete the thermal envelope. We have a hole in it, and we have an unconditioned room on the other side. Good question. State amendment allows you to do that for any method. Next slide, actually. So we now have a requirement for 0.32, and some of you have seen this before, but it's very telling. Because it says the U factor for our fenestration, if we want to go prescriptive, has to be less than or equal to 0.32 on the U factor. So we buy a set of windows, and your window guy brings them out, and we have a bunch of 3.0s and 3.1s and stuff like that, and then we have 1 3.4 or 2 3.4s or something like that. Do we send the windows back? No, we can do an area weighted average calculation and weight the R value of all of them together and see if it complies. So I've got an example here, and I think you saw it just a few weeks ago, Wendy, sorry. Here's an example. I have 4 windows that are 5 by 5, 25 square foot each, so that's 100 square foot of 5 by 5 window with a U factor of 0.35. So I take the area times the U factor, and I get a 35 UA. Now those windows don't comply, do they? They're 3/100ths higher than. Then we have 5 12 square foot windows that do comply. They're 0.32 windows. So we do the math on those. We have 60 square feet times 60 times the 0.32. We have a 19 UA. We have a patio door that's a 0.40. Well, that doesn't even come close to complying, does it? It's way off. That's not a very good patio door. If you're sitting by it, you're going to feel a little bit of a draft just because the convective flows on that window, that door. And then we have a door into the garage, and if the front door, they're insulated opaque doors, there's no windows in them, and they have a U factor of 0.16. And that is a typical number for a good metal insulated door with the wood thermal break running around the perimeter of the door. So we take that 24 square feet twice, 48 square feet times 0.16, and we get 8 UA. And then we finally have a couple of 3x3s at 0.3, and we do the math again, and we have 8 UA. So we take the area times the U factor, and by taking the area, we are what we call an area weighted average. If we just added up the U factors and divided by 5, we get an average U factor, but it needs to be weighted based on how much area of each one of those you have. So that's why we do the area weighted. And in fact, this is what ResCheck does really for your whole envelope, is it does an area weighted average of the whole envelope. So we have 283 square feet of fenestration with a total UA of 0.89. Area weighted average equals that total UA divided by the total area, and we have an area weighted average of 0.31 for all of our fenestration. So if we have that door that's just your typical Santa Fe style door, and we plug in 0.5, you probably won't have something that bad, that 21 square feet. It's going to pass. And I'm not going to get hung up on that. We just want to complete that thermal envelope and not have that cold air coming in from there. Obviously, those doors at 0.16 make a big difference. Dynamic glazing, and I put in some new slides on this because I think we're going to see more and more of this. It's starting to move a little bit. And I actually have some real pictures that I took just a couple of days ago of this. This has been in the code for 2 code cycles now. And what it is glass. Chris?
Can I back you up to that last section there? Where are we identifying the U factor on doors in the field?
Asked for it.
Okay.
The question was, how do you identify the U factor on doors in the field? You can be fairly comfortable that if it's a foam insulated door and the metal doesn't wrap all the way around, they have the wood thermal break on it, that it's going to be down 0.16, 0.17. But you can ask for it. Geldwin and all of the manufacturers have a table that shows what their doors are. When they put the windows in it, they have tables that show when you put the windows in it what it does.
Your RightSoft software, which is very prominent in the
Right.
industry, it doesn't have values near that. They're much higher, much worse.
Right. The software, the comment was software has default values that are much worse. And it does. It has values. They put default values in. If you look at what their default value is for low E glass, it's going to be like 3.8 or something like that. And I guess that's best if you don't know, but find out, Jeff?
Brett, just want a real quick comment here on the door to that cold storage. If you don't have a door there, you're going to have an unhappy homeowner when it starts raining in there, because that hot or that warm, moist air is going to go in there. It's going to hit that ice cold concrete ceiling or metal deck, whatever you got there, and it's going to rain.
Yeah.
And get everything wet in that room.
Yeah. Jeff's comment was, if we don't close off that cold storage, then with the moist air from us living in the house, showering and cooking and all that stuff, migrates in there and we condense. And we have some challenges in those rooms with it raining off the ceiling there. Dynamic glazing. Well, dynamic glazing is it's glass that you literally, by the application of electrical potential on a film on the glass, you darken the glass. And it changes the solar heat gain coefficient on the glass dramatically. And what the code says is you have to have a ratio between the higher solar heat gain coefficient and the lower of greater than 2.4. And the next slide or two will tie that in. It's automatically controlled to modulate the amount of solar gain into the space in multiple steps. You can use it for privacy, and I'll go into, I have some slides that really show this, and it needs to be considered separately from other fenestration in the area weighted averaging. Not to comply with both the high and low rated solar heat gain coefficients. So if you can meet the solar heat gain coefficients someplace in one of the settings, you're okay. So let me just, they call it electrochromatic technology to switch between clear and tinted states on demand. And in commercial buildings where they're starting to use this, they literally are tying it to the BMS system, the building management system, and they have sensors on the roof and everything. And they literally, as the sun rolls across on the windows, they darken and lighten the windows. The building managers have the option to change settings. You can change them from your cell phones. It's pretty amazing stuff. And so when you darken the glass, you can restrict visible light and solar heat. That's in a tinted state. This is in the clear state. So once the sun leaves that window and we're trying to get rid of, and we're not worried about solar gain, then it can go to light and let more light in. Or if we're having too much light, you can dim it down so it's not too bright. It's really kind of cool. So I think those of you out on the internet are going to be able to see those pictures a little bit better. This is up at Cottonwood Corporate Center, which is 6200 and the Belt Route. This is the new red sandstone building built in the back southwest corner. And my son manages this building. He has the glass programmed to where he leaves the bottom less tinted so that we get a little bit of natural light. The sun right now, this is this same wall here. This is south, and this was later in the afternoon about 5 days ago. So the sun has been on this, and it has dimmed down. This is east, and notice it has come back up.
So I know you're not really including this in the public files, but when you have windows like this, how does that affect like your daylight zones and stuff for lighting?
How does it affect your daylight zones and stuff for lighting? It can. But the thing is, you have control of it. If you're wanting the lighting and needing the lighting, you can lighten the glass and get all the lighting in. They actually have all the north-facing glass. The sun never strikes the north-facing glass, correct? But guess what? They have all of it hooked up to their building management system, and the conference rooms that are on the north side, they can dim the glass if they have PowerPoint or they're watching something. I mean, you literally turn your glass on and off. That building up there, I think they have, that was going to be a 450-ton chiller, and by using this glass, they took 50 tons off the chiller size. 50 tons of chiller. That's some serious money, isn't it? 50 tons less cooling capacity is what they needed because they put the glass on. And
Milliwatts versus kilowatts.
I'm sorry?
Milliwatts versus kilowatts.
Yeah, it's a big one.
5 minutes.
5 minutes. Okay. And if you look at this table here, I just grabbed two of them. The U factor for these glass units, and this is for the glass, not talking about the frames. You'd still need to apply them to a frame. but the solar heat gain coefficient goes from 0.38 down to 0.09. Is 0.09 a good solar heat gain coefficient? 9% of the heat makes it through the window. 91% of the heat is reflected back out. And in that forced setting, though, when you go to the forced setting, visible transmittance goes to 1. When would you want to go to the forced setting? Privacy. Privacy. You can take it to that, and you literally cannot see through the glass. You darken the glass. You literally close the window off. It's better than a blind. Pretty.
Great Seinfeld episode on that once involving a bathroom stall. It was either George or Elaine didn't quite latch the door all the way, and they thought it was shut off. But
Okay, Jeff, I'm not going to repeat your Seinfeld comment for everybody out there on the internet, if that's okay.
Is this something you can just add to the glass, or you have to order it?
You have to order the glass. They build.
Like neat glass?
I'm sorry?
Is it like neat glass?
I'm not
Highly
familiar.
polished glass where nothing adheres to it? And it's
It-
supposedly reflects?
It's a film that they apply to the inside surface. So you buy, I mean, they manufacture IGUs, one it's insulated glazing units, and they put a special coating on them, and then they have to electrically connect to all of them with a little Cat5 wire or something like that, and then they hook it to the building management system. View is the company that makes this one. They're called View, and they actually struggled to meet the demand on.
Do you see this creeping into residential, or is it cost prohibitive?
I do. It'll be high-end first, around a bathtub. Lots of glass that faces, you build up on the east bench and you have a lot of glass that faces down into the valley when the sun comes out. You're not going around, and you don't have to have blinds, you're not switching them, it can just automatically do all this stuff. And we're technology geeks, aren't we? I mean, what do you do with your phone? I have a sprinkler timer that cost me $120 and I got $60 back rebate that I could turn on my lawn sprinklers or turn them off from my phone. I see this, growing feet and moving forward. Pretty cool stuff. Obviously it's expensive right now, but as the manufacturing picks up, we're going to see more. I think this is a good time to take we're noon, aren't we? Okay, let's take our 10 minutes. And if you have a question for me, I'm going to ask you to wait and ask it so everybody can hear it. Okay? Or wait till after. Sure.
DOPL, please make sure you tell me. I think some people said I don't need DOPL credit, but maybe you want a self-report, maybe you want it for later. Just let me know, because we want to know before we leave today. So, thanks. We'll do it after the rest of the training.
And we're going to go back online in just seconds. So if you, I'm going to ask that maybe just wait until we're done. All this wire hanging out of me. You ready? We on? Okay. All right. 10 minutes, we'll get started again. Had a comment during our break that actually there's a company making a coating that you can put on the inside pane of the glass that will do this. However, that coating will be, you're not going to be able to take a razor blade and clean your window and stuff, and I don't know how cleansers and kids and everything are going to treat it. Obviously, it's better protected, on the inside surface of the outer pane of glass. And you've used some of these on some high-end homes, correct?
Yes.
So, yeah, I think it's coming. I think we're gonna see some progress on it. It's kind of been, windows have been kind of, well, the only thing you could do is go to triple glazing, and then your air spaces are thin and the panes are close together, and right now it's fairly expensive, but if you're building a high-end home, this might really fit the bill, and it could really reduce your cooling, especially in the St. George area. And then it has those features of automatically controlling it. And by the way, when I did the calculation, the ratio between the low and the high, the code says it has to be better than like 2.4, the ratio between them, and this is like 4.3, so it easily meets the requirements in the code. I've had dynamic glass since I think it was a 2012 code is when it was first put in the code, and now we're actually seeing it, so it's kind of cool to see it come about. And they could darken all of them. Like I say, they're blocking the heat because they were cooling this day in the building, and but still letting a little bit of light through. And when it's just that bottom couple of feet, you're not sucking that much heat in because it's just striking the perimeter of the slab. Okay, any other questions or comments on fenestration before we move on? Okay, let's talk about ceilings. We got our little picture here of our little cardboard rulers that are supposed to be stapled up every 300 square feet. A few things. R values are supposed to be printed on bad insulation or rigid foam board insulation. Blown in must have an insulation certificate at or near the opening, and it should include the R value of the installed thickness, initial installed thickness, installed density, settled thickness, settled R value, and coverage area, and the number of bags installed. These markers are supposed to be every 300 square feet, and I actually, I think they're a great idea. You can stick your head up and look around and see if they uniformly sprayed the insulation in the attic, and it gives the installer a little bit of a guide too. So we have a new R value of 0.49 in our area, and the requirements are based on this assembly type and if it's continuous insulation or not, or if it's cavity insulation, we have to meet or exceed those R values. Now what we need to have a discussion, and I know you guys that have been that are brave enough to put up with me time after time, I beat this up. Insulation is not continuous if it is penetrated by anything other than a fastener, period. The only thing that can penetrate insulation would be a screw or a nail. And so the webs on a truss are more than a fastener, and you cannot list insulation that is blown in an attic on top of the cords of the truss. The bottom cord of the truss is continuous insulation because we have those intermediate webs connecting the bottom cord to the top cords of the truss. Any insulation blown into an attic truss is cavity insulation. And if you want to look, if you go to ResCheck and go to help, there's actually a discussion on it in ResCheck that talks about it. We had this discussion a little bit earlier, and this is something that this is one of my dreams, is that, and this is one that the people from Construction Instruction always push, you know, decide to do one thing on your homes that's a little bit better, and this is one of their top couple, is put a high heel truss on it. What's the R value right here in this area of a standard truss? 3 or 4, 5, 6, 7. It's not very much, is it? It's pretty poor. And in fact, I remember my first house that I bought back in the 70s, and our bathroom shower was right there on the outside wall with a little window, and my wife used to just go nuts because we had actually get all this condensation. She could wipe it dry. She said, we took a shower and I wiped it all dry and it's wet again. Where's the roof's got to be leaking. We got to have water coming from someplace. And if I don't wipe it every day, it starts growing mold or mildew up there. And it just frustrated her, and the sheetrock mud would start, you know, going to heck on you and everything. Well, it was condensate. It was so cold there that all that moisture from the shower goes up and it condenses on that corner there. The tables are written, the R49 in the prescriptive table is assuming we're going to have a standard truss. And our insulation in 6, 8, 10, 12 inches around the perimeter is going to suck. It's going to be poor insulation. It's assuming that. And so the code actually recognizes that if you can build a high heel truss and you get full depth insulation all the way to the perimeter edge or the outer edge of the building, we can call it a raised heel, an energy truss, whatever you want to call it. If you can get that full depth insulation uncompressed all the way, covering 100% of the ceiling area, if 38 is required, you can drop it to 30, and if 49 is required, you can drop it to 38. And it will perform equal or better, actually, than if you don't have that. And it actually reduces the incidence of ice dams, because what are we doing back here? Yeah, it's getting cold here. And why is it getting cold? Heat flows from warmer to colder. So the heat is leaving. Where's the heat going? It's coming up here, and it's melting the snow on the roof. And so we melt the snow, but it's cold right here, and we build a dam, and we get ice dams. So we can minimize our ice dams if we do the high heel truss. And we can reduce it. And that reduction, again, was only supposed to apply to the prescriptive path, but the state amendment allows us to use it on any path. Ceilings without attic spaces. The code recognizes that you might build a house with trusses, that you can get R49 everywhere, but you might have the master bedroom or a library or something that sticks out, that's going to be stick framed, overbuilt on the house and then sticks out. And it might be, 2x10s or something like that, or 2x8s that you cannot get 49 in. And so you can have up to 500 square feet or 20% of the total insulated area, whichever is less, can be a lower insulation value, and where it requires more than R30, you can put R30 in it. So you can't build it with 2 by 6 and put R19 or whatever in it. You need to make it at least where you can get an R30 in it. But again, you have those limits on it. So if it's a 1,000 square foot house, you can only have 200 feet. If it's a 10,000 square foot house, you can only have 500 square feet. So it's whichever. Wendy?
How do you measure that 500 square feet, floor area or actual ceiling area?
The question is, do you measure floor area or ceiling area? I would measure ceiling area. I mean, that's really what our heat transfer, our heat loss through the building is going to be based on ceiling area. You know, because we're insulating up against the rafter in that case. You know, it's not like we're insulating in the horizontal plane, we're insulating on the rake of the roof, right? So that's the way I would do it. Chris?
Are you having experience or issues with permeable or non-permeable insulation in unvented spaces?
Question is condensation issues basically with air permeable or non-permeable insulation, and guess what? We're going there. So yeah. And that's simply an exception to allow you to have a little flexibility in your design. And my next line is IRC has requirements for unvented attics. So you were thinking along, great minds think together here, Chris. And so this is not in the energy code, but I brought it over from chapter 8 of the IRC, the residential code, because if we have an unvented attic space, we have a set of rafters, and in my HVAC days, I did a ton of work up in Pine Brook and Park City and all those communities up there, and Midway, and almost all of them were 11 7/8 TJI rafters that they would net and blow them full of insulation. And then I may or may not have a call from the builder later and go, you got to help me. I'm getting moisture running out where my glulam beams are exposed. It's finding sheetrock falling down and dripping down the side of the glulam beams. And it was condensation collecting on the underside of the roof sheathing, because why? What do we do when we live in a house? We breathe. We bathe, we cook, water plants, we have pets, we do all these things that create moisture inside our house. And then we resist mechanically ventilating our houses, and we trap all this moisture in the house, and as warm air rises, it rises up through that blown insulation. And what's the temperature of the bottom side of the roof sheathing? Pretty close to outside temperature. And when it's cold, it's below dew point.
So
Troy?
Can you show on your picture where that was condensing then? Just at the bottom of the ridge beam?
Well, this picture has insulation on top. If we did not have this rigid foam insulation on top of the roof deck, we took that second roof off, and we just had our standard rafter, the moisture, and we have can lights in it, of course. We migrate up through this insulation because it's air permeable.
Oh, so the underside of the roof decking is where you were getting.
So the underside of the roof deck is cold and it condenses. What do roofers do when they do a roof replacement nowadays? They give you a bid on what it's going to cost to place your roof, and then they tell you it's going to be so much for every sheet of OSB or plywood I have to replace. And they get up there and they walk around on the roof and there's a soft spot, and here's a soft spot, and there's a soft spot. And those are from that type of thing. They're from people putting bath fans and venting them in the attic, and all that moisture strikes a certain spot on the underside of the sheathing. Well, when we don't have a ventilated space, hopefully attic ventilation is going to take care of it. But if we don't have it, we're going to have moisture condensing on the underside of the OSB. And OSB stays wet very long, and it's junk. It really is. So what 806 says is we have to have some air impermeable insulation. We have to have something there that, so when that moisture comes up through and strikes a solid surface, that surface is warmer than dew point, and so we're not condensing. So how we can do it, yeah, we can put some layers of foam on top and then screw sleepers or screw the OSB, the second layer of OSB down so you can roof to it. And Climate Zone 5 is R20, Climate Zone 6 is R25, and then the balance of your insulation can be bat or blow. Or you can spray foam it and then bat or blow the remainder of your required insulation underneath it. This is actually in the code for roofs. We haven't put a mandatory requirement in the code for walls, but we're moving that way, as we saw with the prescriptive table on Climate Zone 6. If you go prescriptive, you have to put some continuous insulation on the outside to do the same thing, to stop that moisture that's moving through the wall from condensing there. Now, someone's going to ask, what about smart membranes? They do make some membranes that you can just bat it or blow it, and then you put one of these smart membranes that actually stops the moisture, but if there's moisture inside, it allows it to dry. And the theory is any moisture that's in there already, we give it the ability to dry, but we stop new moisture from getting up into that cavity. Our challenge with it, and we quit accepting it in our canyon areas where we were having the problems, is simply because you take this smart membrane, and it's very specific on how you have to tape and seal and everything. You know, you caulk it where you come down and meet the edge of the wall. It's like a vapor barrier, but it'll allow the moisture to dry out that's in there. So you seal it all up and you tape around your cam lights and you tape the seams and you caulk and everything. And what's the chance that your drywall people are not going to cut a bunch of holes in it with their routers? 0. And that's why we quit allowing it, because we were still having problems, and every can light, every ceiling box and everything, the smart membrane was cut. And the manufacturer specifically says for the smart membrane, it has to be sealed, completely sealed. And I think it's almost impossible to ensure that it stays sealed. I mean, you can make the case, you builders, you can make the case with your building official, and you know, that's fine, it's up to you. That allowance of a smart membrane is an alternate method. The code doesn't specifically allow it, but it is it's an alternate method that the building official can approve. So we can spray foam and do it that way. It's a closed cell foam or some other method to control condensation. Okay, so we have a ventilated attic. We have to have our baffles, and we have allowances that you can have a baffle every third one. And you know, we have them adjacent to soffit and knee vents and stuff like that. We need these baffles so that the air gets up through it. We need to maintain the opening and extend to the top of the insulation. Can be any material. And I threw in a last comment that I haven't spent too much time on before, but I've actually been involved in some cases where attic mold, lots of attic mold. And any of us spends much time in there, we're going to find it. And in every one of them that I've been involved in, the issue was we had poor attic ventilation, or it was restricted. And I'm going to make this statement, and I haven't collected scientific data and analyzed this completely, but just from my observations, and this goes for the jurisdiction I worked in too, I think most of our attics lack sufficient ventilation. I think we're claiming a whole lot more ventilation for ridge vent than you really get, and even worse is we're claiming a huge amount of air coming in through soffits when it's really not coming in through the soffit. And so I went to a manufacturer's website on vented soffit, and so we have a 6-inch, here's a 12-inch wide piece of soffit vent, you know, with 2 ribs. 2 panels in it. Both of them stamped fully for ventilation, and the net free area of that piece of soffit is 3.5 square inches per square foot of soffit material, which means if you have 41 square feet of soffit, if you only have a foot of soffit, that's 41 foot in length. You get 1 square foot of ventilation. Now, what are we supposed to have? If it's half and half high and low, 1 square foot per 300 square foot of attic area. If it's not equal high and low, no, it's 150. If it's not equal, it's 1 per 300 if it's equal high and low. I don't think we're getting it out of our soffits. And they put it up all the way around the rake of the gables where you don't communicate. You have a truss there that's blocking it, right? You don't get any air moving in through there. And then you have cantilevers sticking out and you don't have any soffit for that area. Do we really have enough soffit vent to let the air in? And I think in most cases, if we get 1 or 2 square feet in through our soffits, we're probably doing well. And we have a 2,000 square foot attic that we're supposed to have a whole bunch more in that. So, the energy code wants that baffling and they want the air moving through there. And it's not only for moisture, but it's for energy efficiency. I've spent way too many hours of my life in hot attics. And someone else that does HVAC knows what I mean. And when you can't touch and hold on to the trusses because it's too hot, we're in the 130, 140, and 150 degree range. And I've been in a bunch of them that you had to wear gloves because you couldn't balance yourself and hold on to the trusses because it was too hot. And that just makes your cooling bill horribly expensive. Prescriptive requirement, all attic hatches and doors need to have a weather strip and the insulation has to be secured to the panel. You go crawl into any attic around here in the valley, and if all they have is a piece of bat that the insulator left there to set on that panel, I can guarantee you that 99% of the time it's not properly in place. And most of the time it's just sitting off to the side. So whatever insulation you use, and it has to be the amount required, it needs to be secured to that panel. I just went and glued several layers of polyiso on mine and just glued them on it, and then bought that really expensive piece of foam weather strip tape that it cost me $2 at Home Depot, and sealed my door, and it made a big difference. And then of course we need an insulation dam around that opening. Something that I in fact someone, I think it was someone, I can't remember, someone last month or two argued with me about this. If you have a door going into an attic, that door does not have to be R38 or R49. If it's a door, it's a wall. So it needs to meet the fenestration requirements in the table. So it's a .32 door is all it has to be. It doesn't need to be a 49. And that's been cleared up and spelled out specifically in the code. Metal studs, I'm just going to really briefly touch on. Metal studs are straight and they stay square and everything else, but they're a thermal conductor. And you get so much thermal bridging that the residential energy code has put in, and so does the commercial, a table that identifies how much heat you bridge out through a metal stud. And so if you have a requirement for R20 in a wall, in a wood frame wall, to equal that, you put nothing in the cavity of that metal stud and put R14 continuous on the outside of it or the inside of it to equal that. Or you can, even if you put R21 in the cavity, you still need to put 7.5 continuous insulation. What that's really saying is, I have a 2x6 metal stud wall and I put R21 in it, and a 2x6 wood wall with R21 in it. To make them equal, I have to add 7.5 R value on the metal stud to just equal the performance of the wood. And the wood doesn't perform perfectly. Okay, can you guys see that? This is my neighbor's house, and I stuck these in just before I taught my last class over in the other building here. And it had rained. This was on March 25th, Sunday. First thing in the morning. Can you see the wet spots running up and down the wall? Can you see the studs? Now, and you can see where the rim is. And what does this tell me about Fred's rim joist? It's not insulated very good. Well, there's insulation shoved in there, but it's not fit and it's not doing a very good job. Because heat is coming out and keeping wherever the studs are, where the blocks are, it's dried the surface, right? Now, when I took this picture, I thought, I wonder if the rain was striking there, but you know, when you looked on the front of the house, it was the same thing there, and as you looked to the back of the house, it was the same thing there. So I was thinking, well, the rain didn't kind of switch around, so it hit everywhere. So I thought it was condensation that was occurring on the outside because it was cool outside and condensed. And where the heat came through and dried it out, there wasn't condensation. And so 2 days later, and you cannot see it here, it's just too bright in here. I'm going to shut these off for just a minute. The camera guy might throw something at me. Well, I can barely see it, but we still have the streaking. And we didn't have any rain that night. Well, that same thing's happening on the inside surface of the OSB, isn't it? Yeah. So that's the whole thing we're talking about. We didn't have any rain. This time we did have rain. We had moisture in the air, and because we had a cold surface where the wall's insulated, we had moisture collect. And as soon as it warms up outside, it dries off. It's a lot easier to dry off on the outside than it is inside the wall. And what it does show is the thermal bridging. These are wood studs. What's our value of wood? About R1 per inch. So a 2 by 4 is like R3.5, a 2 by 6 is R5.5. Put the OSB on it, it's roughly an R6. And we're putting 20 in the cavity, so we have 20 for part of the wall, and then we have R6 for part of the wall. And you know, we're between 15 and 20% wood, depending on how many studs they throw in there. So it significantly impacts the R value of the wall. And some of them, you've seen this, we can take and we can put continuous insulation. We can put continuous insulation on the outside and reduce that thermal bridging. Now I took these two pictures, and some of you have seen these, and my wife tells, well, I won't tell you exactly what she says about me, but she says I'm a little disturbed on the way I go after energy efficiency and some of the things I've done. So here's a room that I just remodeled last year. And there's a window right here, and you can see right here, if you look real close, there's a little return wall. And I have a closet that's right here going the other way. And this is the back wall of my closet. So what I have done on this wall, the whole back of my house, I pulled the siding off and I put 1.5 inches of polyiso all the way up, 2 stories on the outside of the house. So that's about an R9 continuous on the whole outside of the house. And I did that, and a couple of rooms ago, I would get the thermal camera out, and it wasn't as pronounced as this, but you could still see the studs fairly well. And so I really geeked out. And if you can see closely, you see what I did? I put 1/2 inch of polyiso on the inside face of my studs, but since I put it on the inside face, then my cavity was 4 inches deep and I was going to put a 3.5 inch bat, so I cut and fit 1/2 inch of polyiso back in against my OSB. You're laughing at me, Larry. 46 years this July. And I did this on a bedroom and a laundry room. And so this is after I've done all that. Now what's the R value of a 1/2 inch polyiso? 3. And so this wall here has, this has R13 in the cavity, and that's it. There's nothing on the outside. And you can see the heat loss going through the studs. It's pretty pronounced. This wall here has R9 on the outside continuous, R3 continuous on the inside basically, and an R15 bat in the cavity, and I did not put a vapor barrier on it. And my studs have almost disappeared. But the thing that's kind of cool is you can put your hand on this wall and you can put your hand on that wall and you can notice the huge difference. In fact, my wife opens the closet doors now and she says the closet is cooler. You can feel it because we have the heat loss in there. Now, yeah, this is kind of ridiculous, and it probably took me to do that bedroom and that laundry room. It probably took me an extra 8 hours or something labor, but I wanted to see what it did, you know, and it made a big difference. And you can see the screws. Why? Because the screws penetrate that 1/2 inch of foam, and they're a thermal bridge. And so that you can see the screws because the heat's drying off from those. What number am I on? I better hurry it up a little bit. Knee walls. If we have a knee wall, we need to be putting something on the back side of it, some type of air barrier. For 2 reasons. Number one, if you do not, we have a convective flow. The air against the drywall is going to warm and rise, and we're going to get a convective flow in that attic space. So if we put Tyvek or we put OSB or we put something on there, we're 6-siding the insulation, and then it performs the way it's supposed to. If we have the air moving through it, it's not going to perform the way it's supposed to. Our rim joists are walls. That rim joist is a vertical surface, and that rim joist, we have the same issue. And I've got a slide we'll talk about a little bit more on there. If we do this like this, we should be blocking here to stop air moving back and forth. All of our insulation should be bat type insulation, fiber insulation should be enclosed on all 6 sides. So we need to address that in these locations. And like I say, we'll touch on that again. Wood frame walls, the change from the Utah 2012 code. So when we adopted in 2017, we went from a 15 to a 20 plus 5 in climate zone 3, and from a 19 to a 20, 19 to a 20 plus 5, or 13 plus 10. So this one's a big change. You can get 21 bats, R21 bats, so it's not, you don't have to net and blow, but I sure like it. Mass walls, insulated concrete forms, or other concrete walls that you put continuous insulation on. If you have a mass wall, and we're assuming above grade, your insulation requirements go down, and it's because outside, inside and outside, what happens? Heat flows from here to outside. We have somewhere around an R12 to 15 on the inside, and then the same thing on the outside. And what does that do? With concrete sandwiched in between, concrete's a poor insulator, but it has a lot of mass, so it takes a lot of time to heat it up, and so it kind of slows down the heat flow through the wall. In fact, that mass wall, if half of your insulation, at least half is on the inside, you only have to have R13 to be equal to R20 in a wood frame wall. Floors haven't changed, it's R30, and I don't think they're going to change. There is an exception in there if you have a smaller framing cavity, So you have just a short floor system with 2x6 or 2x8, you can go as low as R19 in that cavity as long as you're filling the cavity. So if it's a 2x6, little bathroom extension or whatever you put on, you can put 19 in that. But whatever, if it's a 2x8, you need to fill it, so it's going to be like a 20 or 24 or something like that. Over unconditioned spaces, you can either have a vented crawl space or you can create a conditioned crawl space. You can put continuous insulation. Now this insulation is supposed to be put up all the way against the floor, underside of the floor sheathing. However, you can put, if you choose, you can put rigid foam insulation on the bottom. You're going to have to go to R30, but then you're going to have to make sure you treat the rim joists all the way around as a wall, complete with an air barrier. What's a below grade wall and what's an above grade wall? If it's 50% or more, it's more than 50% below grade, it is a basement. We call it a basement wall, and we go to that basement wall table. If it's less than 50% below grade, then we just call it an above grade wall. And this is an above grade wall, obviously. And below grade walls have a smaller or a lower insulation value because why? Because the delta T, the difference in temperature between inside and outside, is smaller because what's the temperature of the ground? It's going to be above wintertime outdoor temperatures. In fact, once you get down to about 3 feet, it's 50, 55 degrees and pretty consistent, that temperature. So we're not going to have as much heat loss. So that's why we have a reduced insulation requirement. Slabs. Do we require insulation on a basement floor slab? No. The only time we require any insulation there is if it's a radiant heated slab, and this is a below grade slab, you have to have a thermal break all the way around, which includes a break from the slab to the wall and a break from the footing. So sill seal or expansion or something like that, just so we have a thermal break so that radiantly heated slab, the heat's not driving and wicking up the concrete walls, because it really will. You can see a house with radiant heat if you take your thermal camera, because that above grade portion, that exposed part of your foundation wall will be significantly warmer because we have that heat driving out into the wall, and then we have the insulation on the inside, and it's just going right up back behind it.
Brent,
Please,
we're also gonna have an R5 on that.
slab on grade.
Radiant.
If it's
Radiant slab on grade.
radiant slab on grade requires R5 underneath the whole
I
thing.
didn't hear that, okay.
Yeah. If it's basement, not slab on grade, there's no requirement for R5 underneath the whole thing.
Really?
Yeah.
What about half the
Still
house?
good practice.
Half and half, like
Half the house is
or like this.
above ground and, yeah, like that.
You should at least put underneath until you reach a point that the slab is at least 2 feet below grade. That's kind of that's the trigger. 2 feet.
Minimum,
When you hit 2 foot below grade,
I mean the minimum amount of insulation.
R5 underneath. So you would want to go R5 in to where you're sure you're at least 2 feet below grade. But your slab edge insulation, which in our climate zones is R10, we have to add another 5 to that too. So it'd be R15 on the perimeter.
How would that affect
Vertical.
RCI? I mean, insulated concrete forms, if your exterior walls are.
Well, if your exterior walls are insulated concrete forms, you don't have a perimeter edge insulation requirement because your insulated concrete forms took care of it. Yeah, I'm a big fan of insulated concrete forms. I really am. I think they've got a bad name because, A lot of homeowners, do-it-yourselfers, tried to do them and they did them wrong and they failed and they just turned into disasters. But I'm gonna have to hurry, aren't I, Becky? So how do we treat our slab on grade? And I know it's a challenge, and it's a big challenge, and in large homes and in commercial buildings, our slab is actually a structural diaphragm that's tying foundations and everything together. But it's something, if we want to approach net zero, you're gonna have to do it. If you want to build a super insulated house, you're going to have to do it. And you might have to put it on the outside and protect it. But these are some of the methods you can use. Climate zones 5 and 6 require R10 unless it's hydronically heated, then it has to be R15. Climate zone 5 has to go to 2 feet, either deep or 2 feet counting down and in. Climate zone 6 is 4 feet deep. It does not count if you don't have a thermal break at the edge of the slab somehow. If you have to make this continuous, then this is your only choice. The code does allow you to do bevel cut, and everybody knows that if you do that, you're going to break it off when you're trying to nail a tack strip or something like that. I have allowed, and I know a lot of people allow, if that last 3.5 inches is concrete expansion or an inch of foam or something, making sure we have the thermal break. Crawl spaces, if we are going to do an unvented crawl space, we have to have a class 1 vapor retider, 6 mil plastic or heavier, everything taped, run up and sealed against the wall, then you bring your insulation down. I need to take that yellow out right there because you don't have to insulate there. But this has to be insulated all the way down. And if that vapor barrier on the ground is not sealed really well, you're going to have problems. I just helped a guy in Provo Canyon because he had a ton of mold in his crawl space because they just cut the vapor barrier and ended it at the edge of the footings. Sunrooms, I'm just going to, because of time, basically load these requirements. If you build a sunroom and it is conditioned independently, you only have to have St. George R19 in the ceiling, 24 in our climates here, wall insulation R13 all the way around, windows 0.45, skylights 0.7. If you are not conditioning your sunroom, we don't care. It's not a conditioned room, so the energy code doesn't apply. If you put on a sunroom and you remove your door so that it's part of your house, then it has to comply with the standard energy code requirements. You can only use these if you thermally isolate the sunroom from your house. Air leakage, and these are where we're going to wrap up here in the next 7-8 minutes. We have air leakage all over. We just want to touch on, we do have air leakage through the envelope. It is part of our envelope that we're concerned about. That's what these guys test for with their blower door testing. They're testing how big a hole do you basically have in your envelope when you add all those holes together. And it leaks in all these different places, and so we're doing foaming and caulking and all these other things and sealing around boxes. The code without amendment says that without amendments, every home, every thermal envelope in Utah should be blower door tested. By amendment, we don't have to blower door test unless we choose to, and if we choose not to, then we just have to make sure we insulate it properly. And we have a checklist, and in fact, I printed the checklist out of the code for you to look through. We're not going to have time to go through it, but we are going to touch on a couple of things. So these guys come out and do a blower door test if you choose to do that. And by amendment, we only have to get down to 5 air changes per hour, which isn't very hard, is it, guys?
Single family on basement, no, it's pretty easy. Multifamily, far more challenging.
A multifamily is a lot harder challenging. In fact, we ought to have a discussion on that for one of these classes in the upcoming year on multifamily and why they leak. So we do this test and it has to be that tight, or we field verify according to that table. And if it is tighter than 3 air changes per hour by code, we have to mechanically ventilate our house. We have to do something to ensure we maintain the air quality in our house by either bringing in some outside air and positive pressure in the house, putting in an exhaust fan, or putting in a heat recovery ventilator. That ventilation is going to be the subject of our next one. I just want to, tie in that that's what we're going to talk about next time. If we have a tight envelope, we should be mechanically ventilating. And I am going to be so bold as to say we should be mechanically ventilating everything, period. We're making a mistake if we're not. Here is a snapshot of just a piece of that table that we should be following. And it talks about your insulation and substantial contact, continuous alignment with air barriers. And one of those things that we're supposed to do, and I don't have it here, but I want to refer to this sheet you have, is if you take this sheet and you look at, and those of you out there on the web, if you look in your Energy Code 402.4.1.1 or in Chapter 11, 1102 4.1.1, and you look at rim joists, it says rim joists, of course, should be insulated, and it says rim joists shall include the air barrier. What does it mean for a rim joist to have an air barrier? How far back do I? Well, here's a rim joist. Okay, we need to put insulation in there equal to a wall because that's part of the wall. How do we complete the air barrier on the rim joist insulation? Spray foam insulation is the answer there. Can you take an R21 bat and stick it in there and take a piece of Tyvek or a piece of OSB and cut it to fit inside the I-joist and caulk and seal around every one of them? You could theoretically do that and create an air barrier. Is that realistic? I'm sorry, Wendy? Yeah, it is. It meets the definition of an air barrier. Not all building papers do, but Tyvek does. You need some type of air barrier to stop the movement of the air through the insulation. The only logical way to do it is spray foam them. Now, with our amendments, and this is going to be kind of my closing thing here, with our amendments, you don't have to do that if you choose to blower door test. Now, I disagree that I don't think that's what we want to do. Rim joists are a real source of problems. We have
The exterior of the wall?
yeah, the exterior.
You need a Tyvek going all the way down the exterior.
It's covered on one side, but you need to enclose the other side. See, we have fiberglass insulation exposed on one side where the air can move around in it. Think of, and you bring up a great question. For fiberglass insulation to be effective insulation and to perform at its rated R value, it has to be in substantial contact with an air barrier on all sides. So we do that most of the time because we put an outside wall and we have outside sheathing, we have drywall on the inside, we have bottom plate, top plate, and studs. It really is not effective. You take a thermal camera in a building that has scissor trusses over half of it, and then you drop down to flat truss and you have that little wall section, and you stick up your thermal camera. Number one, you see all the insulation bats that's fallen out, but you can also see all the air movement that's going on within those things. So per the table, per the code, and per the amendments, if you choose, and I'm not saying everybody's enforcing this, if you choose to not blower door test, you really should, your code official should be requiring you to spray foam your rim. Now,
That's after the insulation footing.
no, just spray foam the rim. And then if you want to put more on it, you can.
Cause I'm looking at your rim board, Tyvek, and now you're saying spray foam it and then insulate.
If you want to put more insulation,
Moisture buried
but
on the inside.
but you should put enough spray foam to really meet your R19 is what you, to meet your insulation requirement.
So don't insulate the rim joist, you're saying?
I'm saying insulate it with spray foam
Oh, yeah.
and accomplish both purposes. The crawl spaces, that is one of the very first places that we have mold issue. Absolutely. First place we have the mold issue. We have a lot of air leakage out of them. We have a lot of mold in our rim joists. That's all of our time. It's time to break. Thanks so much. Thanks for the questions we had from online, and hopefully we'll see you in a month. Bye.
If anybody came in late or got the certificate that you want to have emailed to you,